welcome all of you. Namaste. I'm Dr. Amit Kumar Singh from IIT Jammu. Basically, I am from Meta Antenna Lab, IIT Jammu, which is part of Department of Electrical Engineering. IIT Jammu is one of national importance institutes established by Government of India, which is in particular for academics and research. Here in our lab, that is Meta Antenna Lab, we work particularly on cutting-edge technology that is towards advancement of society as well as communication technology in particular. So in case of millimeter wave technologies, in Meta Antenna Lab, we work on those kind of antennas which can be the more emphasized for application point of view. Either it is 5G technology, 6G technology, or various satellite applications. The same kind of antennas we are developing here for defense applications such as for radars and multiple accessible communications as well. And we do the most of the design by using software controlled metamaterials. Means those materials which don't have the naturally existing property, actually we nurture them in some different manners. So here just I am demonstrating some of our products. So here I have the first product which I want to show all of you. So this is in particular millimeter wave high gain reflector antenna. So this particular reflector antenna have one central feed patch antenna, and that is specialized distribution on the surface, where on the particular distribution on the surface gives very high gain for this particular patch, and specialized for this particular antenna, the tested gain of this antenna is about 20 dBi. So the replica of the same antenna, to achieve beam steering, what we can do is we can have second reflector design for the same feed, and by using this particular feed, now we can achieve the beam steering till plus minus 15 degree. That means in the plus minus 15 degree direction, we can have perfect control over the beam, that too with a gain of about 20 dB. To further achieve more beam directions in different angles, that is till let's say plus minus 30 degree direction, here we have the third reflector which we have designed, and by using this third reflector we can achieve a gain of about 20 dBi, and again till plus minus 30 degree direction. So our second antenna which we have designed here is one of very small miniature antenna, that is basically a green lens antenna, that is graded refractive index material based antenna. So this particular antenna is again having 3 beams at a time, and that too can be controlled by switching applications. So at a time we can have 3 beams, and we can have switching control over the beams from plus 15 degree direction to 0 degree direction to minus 15 degree direction. So this is one of the advancement of this particular antenna. Although it is small in size, but gain of this antenna is again pretty high, that is again 20 dBi. So that is one of the finest application of this small antenna, working at 28 GHz band. Now coming to our similar kind of design, which we have worked forward for third one, that is this particular design. So this particular one is again designed for waveguide radiator, which is operating again at 28 GHz band. So by having 28 GHz band, this is meta-surface lens which we have designed, and by using this meta-surface lens we can achieve gain enhancement of about 10 to 15 dBi. And if you can see in the back side, the setup consists of the radiator itself, where the radiator is this horn antenna, the waveguide antenna in particular here, if you can see, and here we have the meta-surface lens placed at a particular height. So if you can see, you can visualize this complete structure, and all these complete structures, when they will be tested in general, you will realize that how in particular these antennas are going to be useful. So this particular antenna also going to have a gain of about 20 dBi, very directional beam, and very useful as far as the applications are concerned. So these are the major achievements which we have for our lab as of now, and all these types of antennas are tested in our anechoic chamber facility, where we have full-fledged facility available till 40 GHz application. I will be showing you with my team, and I will be demonstrating its measurement part and application part in our anechoic chamber facility as well. So now I welcome all of you for this Meta Antenna Labs anechoic chamber, and here we have this anechoic chamber with us, and this testing facility is self-sufficient to measure all the kinds of radiation characteristics till 40 GHz, and that is specialization of this particular Meta Antenna Lab.
Dr. Zamir Wani, working as a project scientist here at Innovation Center, I2EDC, IIT Jammu. So since we know that millimeter wave wireless links are usually power limited and suffers with various issues such as huge propagation losses and other issues like signal blockage. So to address such issues, we have designed a prototype antenna, which can have highly directional beams within 15 dB of peak directivity and with beam steering capabilities. Like this is a prototype antenna. It consists of 3 antenna elements placed at the focal plane of this lens. This is a lens designed using graded refractory index technology and realized using metamaterials and PCB technology. So this lens actually enhances the gain of each antenna element to about 20 dBs, and with this we can perform the beam steering to 0 and plus minus 15 degrees.
Hi, I am Ghazali Bashir, PhD scholar at IIT Jammu, working in a Meta Antenna Lab in Electrical Engineering Department. Here we have designed an antenna array based on digital metamaterials, which mitigates the various millimeter issues like multipath fading, low SNR, low spectrum efficiency, and higher power consumption. The digital meta bits are distributed over the surface to achieve a very high gain of 20 dBi, and the beams are scanned from minus 30 to plus 30 dB directions.
Hello, I am Suchitra Tiwari, PhD scholar at Department of Electrical Engineering, IIT Jammu, is here with my prototype that was designed at Meta Antenna Lab, IIT Jammu. So there are various technological barriers that persist in the millimeter wave range. So to mitigate that losses and get the highly directive beam in the broadside direction, lens antenna are the promising solution. This prototype consists of a lens that was designed using a hyperbolic distribution, and this is the waveguide feed that was kept at 54 mm of focal distance. The area of this lens is 78 x 78 mm square. So after feeding this lens with this waveguide, we get a highly directive beam in the broadside direction.
So since just now I have demonstrated the kind of products which our Meta Antenna Lab and the team members, including our scholars and other teammates, they have developed. Now it's time to say you people thank you. But before leaving, if any one of you want to contact us for your R&D related works or any of the contacts for any of the concern, you can contact Meta Antenna Lab, Department of Electrical Engineering, IIT Jammu. I thank all the participants for hearing. Thank you all of you.